Sir, we are live, sir. Please start.
Sure, we can start.
Yes, sir.
Okay. Okay, I'll share my screen and we can start. Yeah. Okay. Good evening, everybody. I just want to just a mic test. Everybody can listen to me?
Yes, sir. We can hear you, sir. Yeah.
Okay.
Slide is also clear.
Okay, sure. Good evening, all. I think let me start. Actually, first of all, I would start with acknowledgements. I think I would like to thank the IITM, the BSc program who reached out to me to have us share my learnings and share my experiences with the team. So first of all, I would like to thank them for giving me the opportunity. Secondly, I would thank my Broadridge, my employer, who has facilitated me to share my knowledge with all you folks. And finally, what I'm presenting is mostly, the work done by my team. So, the team that I have, the MLCO team that I've set up and I've been working with the past 5-6 years. So I would want to just thank them also because most of the learnings have come through those experiences. Given that, let's start. Okay. So what I would do essentially give an idea of context of what at Broadridge, what we do to start with, and then give a little bit history about, how we went ahead and set up this, what I would call ML and machine learning and data science COE, and how we have built up the team or what skills we have used to build up the team. And secondly, then I would talk about specific, essentially what I would call some of the POCs and the production, giving the company confidential data out there, but essentially give an idea about what kind of problems we solved and what we solved, and giving some snippets of what we learned from some of those calls, some of those studies, some of those what I would call some of those use cases. Okay. And finally, I think I would want to just share 4 or 5 simple, learnings that probably will help us in the long run. And as a practitioner, so anybody is interested, what is critical or what we have learned from these experiences. Okay. Okay. At the Broadridge, the company, what we do is we are a S&P 500 company. Essentially work in 4 different areas. What you could see is what we would call capital markets, wealth management, asset management, and corporations. I think why I'm giving a little bit background about the company is to set the context to say that, for any AI and ML solution, what is critical is what I would call the fuel to run any solution is the data. So, and then from these transactions, what data we get or what we do and how the data is critical for our building those solutions. If we look at it high level, I would say that we have got into 4 areas like the capital market. Essentially, that all of you, I understand that. I don't know if some of you are familiar with buying and selling some shares in the stock market, or buying some fixed income securities from a bank. Some of these, essentially, these are what we would call, the way you want to manage your money, actually save money, right? Essentially, that is where people buy and sell, they save and then for future, and then they basically what they would do is how they would use it in some point later. So essentially, equity markets facilitates that. So biggest challenge, capital markets helps us to, we have got solutions in that area. And what we would call when somebody has got a wealth, they would like to know, how their portfolio is doing, what I would say that, what the returns are getting, or essentially more in the context of there are multiple intermediaries out there which deal this particular one. What I would say is essentially the wealth management area. And then the people who sell, like, for example, all of you, I think rings bell, if you talk about HDFC mutual funds or Axis Bank mutual funds, these are all asset management companies, right? We facilitate transactions for those companies, essentially, if you look at it that way. And these are mostly on the worldwide, I would say, I've given an Indian example to set the context that so that you can understand what what are the various asset management do. And then corporations basically means companies need money. They do raise money and they manage. They have got a legal end, what I would call mining. Like, for example, if somebody is a shareholder in some company, what they need to do is they get communication with the company because they are part of the shareholders. So, and every year there are some mandatory things that a company has to go through regulatory environment, or they need to every day they need to make they need to conduct annual meetings. So a lot of back end processing happens when a company basically interacts, sells and markets its equities in the equity market. So, and then so that is where what I would call how we work the corporations. And last is customer communication. I think simple example here could be that in India, if you look at it today, we got probably most of us do prepaid billing, but good number of a postpaid billing. Essentially, what I would call is when you do any transaction, you get a monthly bill for utilities like telephone or insurance. So multiple way of communicating. Some selling any financial product or any other solution. What I would say is so these are where this touches the whole gamut of people we interact with. If you look at give you an idea of what the kind of data that comes in system or out, I can just give an example here. We are actually, around 70 to 85% of the equity markets. We are leaders in investor communications. That means any company that wants to communicate with us, with the shareholders, probably 70 to 80% of this company are our customers. And on an average, we do process around $12 trillion US dollars of equities and fixed income securities every day. Equity, fixed income equities could be value could be high, but the number of transactions, whereas equities are converse actually. The number of transactions could be huge. So the kind of data that comes in for a period of time is humongous. And then every year we say we basically do around 6 billion customer communications are there. So this basically encompasses good part of what I would call at an individual level or at a lot of whenever you do communication, it could be coming from multiple people, multiple sources, what I would say. But still, if you look at it, the volume is humongous. So there are a lot of opportunities for us to leverage this data that is flowing in through our pipes. So that is where how do we use all this we've got to build some solutions or that can help in opportunities of increasing our revenue, or opportunities of of analyzing risks, or predicting something is likely to happen tomorrow. There are a lot of different kinds of solutions can be built with the kind of data that flows the systems. Yeah. So to give a summary of it, let me give a little bit background of myself here. I have been in the industry now for 30 years. And then I started as a developer 30 years back in early 90s after graduating my IIT Madras master's. So, and then to start with, data science and ML was unknown at that point of time, right? But around I would say around 2013 or 2014 timeframe, we wanted to really start, with a lot of data coming out and the technology being progressing. We felt it's a time for us to see what this AML solutions, how we can then help us, and how we slowly start and see what solutions we can build. That's how the ideas seeded for us sometime around 2013, 2014 timeframe. So till that point, even I am not aware of much of all these machine learning algorithms or big data technologies. None of it I was not aware at this point of time. So the first thing I had to do at that time was I think I would say Coursera was just taking off at that time, and the university in US basically has put a lot of 6-7 courses that are available that are put in the freezers. So what I did at that time was started, went to those 6-7 courses and went through and then learned. That's how I started working, and then I build what I would call build the basic, learn the basic tools and techniques that you can use to build industry scale solutions. That's how we started. So what I would want to drive at this point, you can see here is learn any big data AI solution is not just about using ML algorithms or big data, whatever. It's more of, it's a combination of multiple sources. The reason being, it's the expertise that we have to bring together to bring a successful solution out requires multiple domain expertise, multiple technologies, and then you need the tools and techniques that by which you can use this and bring a solution out there. So if you look at it, we had to actually go through a lot of data visualization. We have to find out what are the products available in the market, and then how do we build the what I would call the expertise that people can really, that we can really start working with. That's when we coordinated with a third party provider who helped us to train the initial set of people, and then that's how we picked up initial skill set. And then we use a lot of technologies basically because without the underlying data that you work on, right? How we can, because most of our data is in the mainframe. So we need to find the technology by which the data can be put, which we can use it. And then the last thing is, I would say the domain expertise is very critical for any ML solution, because you may say that, you want to get some insights out of some particular, data that you got, but you must understand the context on which that data is available to us and that data can be used. So that is more critical than, that is when the domain expertise or what problem you're going to solve, or, which area you're going to tell, that comes into the play out at this point of time. So it's a multidisciplinary, I would say that, any building any solution is a multidisciplinary team that you need to bring it out. It is not just, one particular area. Essentially, it requires technology, people, and then the underlying ecosystem that can help us to build the solutions. So given this background, we started really slow actually. In fact, we really started in a very small way. I started the COE, sometime in 2015 or 2014, 2015 timeframe. With initially, what we did was we picked up some initial cases that we can have quick solution, quick wins. Once we did that, then we went through this normal rigmarole of what I would call POC. You do a POC and then see, first of all, can you solve the problem? Then once you got the problem solved, then next step, what we got is, how can you really can this solution solve some business problem or really can address some particular problem? So essentially, if you look at it, we did some POC for around 6-7 POCs we did. That's when we figured out there are 2 or 3 candidates that really you could punt on and say, we can at this point of time, let us see if we can really productionize them. So we went to the next step of using those 2-3 productionizing system, and then we deployed them. So that is how we started building that. Once we did that, then we started with multiple, taking different use cases and see how we can start with how we can solutionize those different use cases and say take vision. So given this background, what I would say is like what we have worked on. If you look at it, I identify the 3 different classes of problems that we can really solve here. First one, what I would call typically for what we do is a lot of text extraction problems that we do here. Simple example that I can give here is what I would call email categorization, where you would see that, like a simple example could be that, we've got an operations team. There's a common mailbox where 20 or 30 people come in every day morning, and everybody is specialized in a particular area. The problem here we are trying to solve is, given the context of the mail, the text of the mail or the context of the mail, can we classify so that the people who can work on that only color code those mails, so that only the required guys can go and start working on them. That is the first production use case that we did and that we deployed. So this was more of a underlying, we have used multiple algorithms, but the more in the context of this one, this is a more like today, this particular one I would say then is a part of the Outlook feature itself. Every day, every week or every month, I get a mail saying that today you got these meetings, or this is how there's a lot of statistics that are being collected post that. Essentially, once you got that, how this can help is like once when somebody comes in early morning, first thing is they know that which mails each one has to take without they need to look at the bunch of I assume that every day you're getting 1,000 mails. All these 30 guys or 40 guys who are working on this particular problem had to go through each one to identify which is theirs. And once they identify the colored one, then basically each individual one starts working on them. So by the time they come in itself, one level of categorization we did was what, who has to work on what. Second categorization we did is what, is this a problem? Is it a email that needs to be responded immediately, or essentially you can say that some action needs to be taken, or it is just information. So that kind of priority, whether at what priority this particular mail needs to be addressed. So that was the what we try to do here is that. And this is something which probably this helped immediately, to a lot of efficiency. Once you got that, there's a lot of analytics that we could build over it. Like, for example, now you got an thing that when the mail came in, when somebody actually particular one actually looked at it, or they worked on it, and then at what time they responded back. So we built analytical tools that basically says that, are we meeting our service level agreement, saying that, somebody sends a mail request to me that, they want some change to be done. Can I do it quickly? And are we, so that kind of metrics could be derived from that. And then that allowed us to increase the, what we would call the operational efficiency. The same thing, what we essentially, the other problem that we use is what we call as a name and address extraction. Here is a case where given, like statements, like you get, everybody gets a, what I would call a huge file running into millions of this one, right? That basically had an address and a name combined together. The idea is to identify unique names or unique names and location, so that you can go and do a lot of post processing on that. This particular problem actually was something which, what I would call, we did a name entity extractor that was more of a identifying from a corpus of names from the text. Can you identify the name or not? Or given some address, can you say which particular address is? For example, one could be which city that particular address name belongs to, or which particular within the city you could go back and say which particular street. So at that level, you can identify that, the what we would call a geographic location. Like today, typically what you do is, what are the kind of people that are staying in that particular residence security? What is the net worth of these guys who are staying in a particular area and particular region? So a lot of post this, they do a lot of post processing. The challenge here was how do we get names, and then once we get the names out there, it's more of a, time. This is one more problem which is very time critical, in the sense that you get a problem, you get a huge file runs into millions of names, and that we are supposed to get processed in less than a day or something like simply supposed to go and extract that. These are some of the lot of text extraction problems we did that. And the second class of problems that we addressed is what I would call the operational excellence. What in operational excellence is what, like typically what happens is, if you look at it, there are loads which are peak loads that comes in. Like for example, in a particular case, what you got, most of our volume of data, that processing that needs to be done comes in 2 or 3 windows. Simple example, can you guys, all of you know that, right? You only study before the exam, right? All of us know that. Just like that, companies also are like that. What they do is, before a particular deadline, some data needs to be shared. All of them shared just 24 hours or 48 hours before the deadline. That means we have, and then as a part of our requirement, what we have to do is, we have to basically do whatever processing we have to do on the data in less than 48, in less than, in getting in T plus 28, 24 hours, something, and come back and return the data back. So this particular one is a, very variable load where it just peaks out in twice or thrice in a year, rest of the time it comes. So, and then, so you cannot manage a capacity for this kind of an operation to run with the peak load, because number of people you have to employ at the peak load will be humongous, will be disproportionately more compared to what you need steady state. So for solving this kind of problems, this particular one was very good use case for us. The second one is what I would call trade allocations. Here is what we have done is, like the similar assignment problem. Is more of an assignment problem, but like what we do is, like, there is a lot of reconciliation that happens, and once we do reconciliation, a lot of records, there will breaks in records. When the records break, essentially the idea was that who has to work in resolving this particular break is one identifying way of thinking. Given the data that comes in, without knowing, based on past history, can we allocate who has to work on this particular assignment problem? So this is what we did. And then the trade allocations is one other use case that what we did here was, I would say, like today you buy some, like you buy a particular security, from a particular broker. But at the end of the day, come back and say that, this needs to be allocated, 5% of this needs to be allocated to X, another 10% to Z, like that, so on and so forth. So given this text that comes in, can we figure out a way which we can say automatically come back and say allocate that who needs to work on, who needs to be allocated. So this was the other problem that we did that. And the third thing, that essentially what we would call is a risk management solution. Essentially what we would say is on a particular day when you buy or sell something, right? There is an obligation that you take the money and then you pay the money, or you pay the money or take the money and then deliver the security for the purchase, right? Given this, on a particular day, every day this has been run, right? Given this, on a particular day, which trades are likely to not settle? Essentially, that gives us a priori able to say that before the morning, before somebody comes, before somebody starts working, you can always point, these are the trades are likely to not get settled in the day. So it's more of a predictive kind of a solution where you are saying that, you're reducing the risk of last minute scramble to make sure that your settlement goes out clearly. And the last one, probably all of you are very familiar with it, what we call recommender system. And here what we were trying to do is, given some security or something available for trade, given the information that I got, can we predict who is the likely buyer, who are buyer or buyers for this particular security? That was the third kind of solution that really we worked on. So given this, I would want to actually dwell a little bit deeper into a couple of use cases that we have done, so that we go a little bit deeper in what went into building those solutions. Okay, let me come back to the first. I think this is being a very favorite one. All of you are very aware of, that you're all YouTube favorites, and then every time when you open YouTube, you get these are likely you want to watch, right? Or you go to Amazon, you say these are likely ones that you are interested in, you get recommended, right? Typically, what happens is, based on the behavior, based on your interests, there is basically somebody comes and back, they like to recommend. So, but the problem for us is quite different in the sense that our problem is quite different from a typical recommender system. Now, how do we solve this problem is something which we try to build some 2 or 3 models that can help identify who are the likely buyers of particular security that are for sale. The first difference is what I would say that the data set that we get is not humongous. Like typically you don't get millions of customers, or you don't get millions of, I would say, thousands of products. Essentially, the population set that we work is out of thousands. And then the number of bonds that are available could be out of 30K around that. So the data set is typically much smaller, but the same solution can be applied for this. That is the first question, that first challenge that we got. The second one is, when the data that we have got, we only know that somebody has bought it. We don't have much information other than who has bought that particular one or similar one. So the identifies how do we model the behavior of a particular, individual or a broker dealer given this transaction data. So, and then the third biggest difference is typically what happens in recommender system, you don't care about what you're recommending, as in what the essentially here is what you've got some security that's up for sale. Instantly at this point, you're supposed to identify who are the likely for buyers. You're not going to see, it's not the converse of it. Essentially what I say is, why this converse is because typically in recommendation, what happens, depending on your behavior, you get a set of products that you can likely to buy. But here is not that. You have to identify the buyers of a particular product that is only up for sale. So that is quite different from a typical recommender system. So how did we solve this problem? So what are the data that we got? As I told you, we got the transaction history and what I would call the behavior of the particular bond. Essentially, that says that what is the rating of it like. Typically, the rating means basically it gives us the how secure this particular investment is or likely. So there are a lot of multiple attributes. Given this a set of 50 or 60 attributes, we have to identify. And then the third biggest challenge is where the problem is for illiquid bonds. That means what you are trying to model, which recommend a system for a system which is the transactions are very, very frequent, what I would call infrequent transactions. Very means these bonds are not that you can trade on a daily basis, or they happens regularly. No, it's not that. They happen once in a while. So the question is, what, given that bond, the first challenge we had was, what are the similar bonds that this particular one bond basically is similar to? Once we have got the similar, which bonds are there, then how do we go ahead and get the customer behavior from this? So essentially, there's no out of box solution we have to build. So we built our own, what I would call a ranking mechanism, or what we call is modeling mechanism, by which we come with some number and saying that this customer is likely to buy with this particular rating. So we rank the customers based on this, and depending on how many you want, 10 guys who want to recommend, or 5 guys who want to recommend, you basically cut them off and say that these are likes. So that is one. And then the bigger challenge we have is what we call is, for these kind of solutions, these are not what I would call black box solutions. What I would call, these are white box solutions. White box solutions means what? If I make a recommendation, somebody would really want to know why I made this recommendation. Why I made this recommendation, and how I come with this particular recommendation. That was very critical for us in the context of the when we make the recommendation, because to initially, when improvement, somebody wanted clearly to say why you're recommending this. So that is the reason why a typical AI solution, if you go back and a priori neural networks, right? In neural networks, if you see that you don't know how the recommendation has come, there's no for us to go back and change how you came the recommendation. So some of these challenges are there. So that is the reason we use multiple models and see how we can validate our model with the neural networks. Is it giving similar solutions? Is it giving better? So the one other way, what I would say is, when you do any solution, the more of it is not one model that you need to work on. You need to try multiple models and then validate and backtest and come back and say this is the most likely model that's going to get it closer to, and then you need to do a test it out and come back and say that. This is the liquid ones. And then next, I would talk about two different solutions. Actually, intermediate allocation, I did briefly mention a break allocation, right? This is basically, we build this solution for an external customer as a product. So the idea was what, given some historical data, can we come back and then say that these are the guys who are going to solve this, resolve this particular break, or who needs to work on this. So this is more of a, so for this to be successful, what we had to do was, we had to, we went in a step approach. What I would say that, first we did a POC with a specific criteria saying that, my model must be able to at least predict 75% allocations correctly. It must be able to do that. And then we had a very limited time on this, right? So once we did that, the next step of the channel is when we really wanted to build a product. When we wanted to build the product, then the problem scale of the problem changed. Actually, essentially, when we initial set of data that we got was a limited one for 2 weeks, right? And then the scope to make it viable, we had to actually expand the problem to much bigger scope, or I would say, than what we initially started with, because that is when you can get the required sales or required solution is going to meet. So the question here was what now. Like for example, they were the feeds were getting, each data feed they were getting probably as each 50 different attributes running for each particular data set, and there were 27 different data sets, and we have to build models for this 27 with each one to identify which are the not all the 50 columns. People don't use it to come to a decision who is likely to assign this problem to, right? So we have to identify what we did. What we did was essentially we have to build the attribute selection itself. We have to automate the attribute selection itself so that we can quickly come back and say what are the columns of data that was used to come to the decision. So this is where what we would call that is the first criteria. And second thing is what the data is something is not constant, right? It's basically changed over a period of time. So can we build a system that basically does a continuous learning so that every day, there's at least what our initial POC did prove that there is 10 to 15% of the data is fresh every time it comes newly. So when the ones that we cannot allocate, when somebody allocates, now can we build tools dynamically? Then the third point that we had essentially was what, when we generate a rule, right? When you generate a rule and fire the rule, they wanted to come back and say, what is this rule really correct or not? Because at the end of it, there is some other person who's taking the break, right, is working on it. So if it is not, assume that you give 50 breaks to a person who is not supposed to get them. So these are false positives, right? When you do false positives, the problem is that you don't want them to go through multiple cycles, multiple zeroing the correct solution. So the challenge here was what? How do we build a system that has got a continuous learning mechanism by which we could go ahead and increase our accuracy levels? So historically, post going 1 year live, what we observed is we started with a benchmark of 75% accuracies. We started when it went live with 80%. Today we are doing consistently 90% level. So around 10% of around 10% of the data every day goes what I would call learns by continuous learning. Then the solution was built in a super fast time, what I would call in 6 months time. We built the complete product end to end, deployed on the customer side, and it was ready for certification 6 months. That is all. This could have been done without, that is, AI is only one part of it, right? Because the system is sitting in between multiple systems that are being coming out. So how do we build a system that easily works with the underlying ecosystem of the client? So that is one other challenge here. How do we, what technology we must use to represent the data, so that what database you have to use, and then how you're going to generate every day you are learning. So because and then that job, the window of job for running continuous learning will not be humongous. Probably you'll get around 1 hour or 2 hour window a day for you to generate the new rules. So multiple technologies were used here. What I would call, we used clustering, and then we used a classifier that basically generates the rule. So generate the rules. Decision trees were used to get the rules out there, and then to fire the rules. So it is the summary. If I say that any AML solution is not just the AI and algorithms part of it. There is a lot of underlying data. There's a lot of underlying systems that needs to come cohesively work with and meet a lot of SLAs are that required. So that is the challenge that we got to solve on this. And the last one, I think I did briefly mention, right, is that again, example I gave you, right, where what was happening was twice in a year, right, there was you get what I would call data that comes in from probably 30,000 fund houses. In US, probably there are 30,000 fund houses are there. They do all the regulatory filings sometime end of February. So they've just put all the documents come there. So the question was, what there are multiple processes that we do. We picked up what problem you're going to pick up is also a bigger challenge out there, because you want to pick up problems where you get the maximum benefit with minimum effort. So the first problem that we did is, how do we like, for example, documents, you want to identify what is the logical end of a document, so that any filer, for example, I'll give you an example here. HDFC is there. HDFC mutual fund is there. It may run 30 to 40 funds. So typically what happens is the fund houses, they combine all the prospectus, the returns, everything into a single document and give it. So the idea here is what? You need to cut the document, each one, and say that this document is for this particular fund or for this fund house and for this particular fund, and then give a logical break of the document. That was the first step. And why cutting at the exact point is very, very critical is example I can give you here. What happens is, when you build a document, this document, once it's logically cut, is actually gets printed and sent to mail to customers. Assume that you got 1 page extra and you got 50,000 or 60,000 clients. Immediately what happens is you're sending 50, 60,000 pages extra out there. So cutting that exact point is very, very critical. So how do we solve the problem? Typically for this kind of operational problems, right? What happens is they've got what I would call two eyes. Essentially you got two set of people do independently the same work. Once they do, the two people independently do the same work, then there's a merge of these two guys results. Essentially what you're saying is these two people come to the same conclusion on the same problem. If they merge, then basically there is a check mark that this particular one is ready for the next step. Then what happens is, once you go through this process, you'll end up actually someone going what we call go to review process, right? So essentially what we did here was we took out one stream of the automation stream, basically took off the 1% of the one half the effort here, where it was done automatically, and we converged our with the manual operations, and that goes through what we call maker checker mechanism. Once you got that, then the second point was what, like for example, coming to the again classic example of mutual fund, you would want to say that what is the returns of this fund in a 6 months period, what is the returns of this fund on a 1 year period, so and so on. Likewise, the same way, what does it cost for you to become a member of this fund? What is the cost that I'm likely to incur by purchasing this? For example, it could be that today funds may charge 1% as the money as the maintenance fee, as a fund fee, right? So given this, we had to extract something what we call 350 data points needs to be extracted from this particular use case. So given that, what we had to do is pick up, what we did was we modeled and picked up around what I would call 10 points, 35 points, which are most critical and which are done on a daily basis. So that this is the most, means what I would call the most effort, the one that takes the maximum effort, but the number is very small, but at the same time, that gives us huge efficiency. So essentially, we picked up around 35 data points and said that once we solve this 35 points, probably we'll eliminate 80% of the effort. So we did that, and this system has been, I think this is more of an internal solution, not an external solution, that is running internally for now, I think probably for 3-4 years now. And since we went live, I haven't seen any issue that will come up after that. So that's the kind of solution that you could see for this kind of issues. So given this, essentially what this problem looks like, essentially the files are what you would call, HTML files. So, and then it required this particular problem actually required a lot of help from the operational users, who basically allowed us actually what they do. Essentially what you say, they had to give us exactly what they look for, what they have to, we had to basically take those strings and then do a lot of, what I call simulation studies, by which you can say that exactly we can do that, because when we went live on a most critical day, that was on February, when the biggest volume was there. If that day would have failed, nobody would have, the solution wouldn't have the belief of everybody, right? So the challenge was, how do we had to get it, first time we had to get it right. So we did a back testing of almost 3-4 years of data to come exactly and say and test it. And once we are comfortable, that's when we went live. And since then, I think this has been one of internally, I would say that it gave very substantial savings. I don't want to quantify the exact number, but it's pretty, it gave probably good savings on a regular basis. And then, so by that, what has happened is the period which, usually that takes 36 hours for us to get the results out, to get the processing all done, probably is done much more efficiently, much more faster is being accomplished without the peak rush that we have to go through. So, what are the key learnings of all this experience that I talked about? I think I know I tried to rush through a lot, but I wanted to just share 3-4 key things that you really want to that. What is the first thing? Identifying the key problem is very critical, because without the right problem that you want to solve, the best algorithms may not help us. I give a single example here, like, you want to bring an insight, like, for example, most of you process, probably I would say that all the shareholder meetings happen, shareholder records you process them throughout the year and say that, come back and say the insight that, all the meetings are held in May or June. This is an insight that is known, right? So we don't need to do a, ML and AI to basically come back and say this is what it is. So identifying what problem you want to solve and having a definite goal definitely helps in success of any AML solution. The reason being, you know exactly what you're looking for, and then I know that what I would say, how do you get to the end point could be challenging, but clear goal setting helps us. Like for example, in the solution that we brought, very clear that say the client very clearly said that I need an accuracy of 75%, and then I don't want any recalls. That means what? I don't want any false positives. The reason being, the moment you start getting a lot of false positives, what happens is the guys who are using the system, they lose the trust, and they're not going to come back and say, I'm not going to believe in these rules that you're generating. So, and then how do we build how you can build? I'm sorry, I think this suddenly I got this one. Okay, how do you build a solution that basically helps us to the right, pick up the right problem and then right use case that you want and gives the maximum effort. These three are multiple criteria you can use, but identifying the right problem is the most critical one for us to do the next step. Okay. The last one, the second point I would say is, what is this? It's basically without data, nothing works. So essentially the critical thing is you need to have data for us to, so the right kind of data. What do you mean by data here? You look at it. So data by itself doesn't mean anything, right? So you need to identify what is unique about data, what is the data that we need to solve the problem. Are we getting the data or not? Because for us to any ML solution correctly, correctly to at least to have a chance of being successful, you need to have the right set of data, and then without that it doesn't work out. As a couple of examples I told you, right? Essentially the historical data that we got for the documents aggregator helped us to identify what is the right, what we must look at it, and we have enough back testing that we could do that. And then if you want to look at, like for example, the recommender system, you need to get the how do we build network value, saying that, so and so thing is being, can you build, given this data, can you build a network value of it? So these are all depending on the unique data that you got or the correct, the sources that you can explore. That is very critical, identifying the data that you need for solving the problem. And third step, I think I would say, is essentially what I would call the roadmap for successful enterprise. Essentially what you could say, I think the picture is very clear. You are going to test and fail before you succeed quickly. So all your goals towards your milestones must be very, very small, so that achievable and demonstratable. Every time you're able to demonstrate that, it builds on the solution, and quickly you can do that. So what I would call typical, what you would say, divide and conquer methodology, we use that to identify a small problem that you can solve, and then build a solution based on that and successfully, and then anything that doesn't work, quickly discard. Here an example I can give you, where for example we did one, I did for one of the POCs, right? There's an operational POC where we were supposed to extract the like for example, when somebody gets married, right, their name changes. So somebody may send a request saying that I need the name of my account to be changed from X to Y. So now the question was, what for solving this kind of problem, what do we need? We need to extract the data from a or what we call system that basically gets the request system, right? Get that. Once you extract it, once you extract the relevant data, now you have to fire it on the system that basically does the actual change. That is an underlying system, right? It's a huge, humongous system. So now, given that we build the great technology by which you could extract the data, request tickets from a remedy system, and then go through the ML system and then come back with recommendations and fire exactly the data that needs to be read, you automate it. But what we realized was the effort that was spent, the number of requests that we get for solving this kind of problem probably is, people were on average spending, I would say that a couple of resources spending, half a day on this to solve for taking all the requests. Now, do we need such a complex system to really solve this problem? The answer definitely is, no. In that case, right upfront, we said that this particular, so we don't need to work more on this. I know technologically we can prove that, but what I would say that it doesn't solve the business problem. Unless a business case is there, it is really worth it. It is not worth spending that kind of time. And last thing, last insight that I would want to say is explainable AI. What I would say is black box versus white box models. In a business situation, right, you need to really know why it is. For example, as I told you in the allocation problem, when you're doing the allocation, right? What they were saying was, you are generate a rule now. I want to validate whether this rule is really work or not. And then tomorrow, somebody has 6 months down the line, somebody may audit your allocations to say that why this allocation was it. Can you go back and clearly say that, how this got allocated? So making your black box as white box will definitely help in building the confidence solution. And then you're able to actually and then, so whether you want to use a white box model or black box model, it depends on what kind of problem you're going to solve or what kind of solution it is. So these are multiple designs are there, but given proclivity is what in a transaction based system where the accuracies are very high and the risk of failure is risk of false positive is very high, you really want to stick with white box models. That's, I think, I'm end of my discussion. Thanks a lot for spending this time. Let me take some questions. I think any questions are there? Okay, one question I've got one is, what is the best way to learn and understand ML and AI, both core and non-core students? I think, there's a lot of, freeware available nowadays. A lot of freeware available. Like Coursera is very, very good source where I think I picked up my initial thing. And then, Stanford University also has basically made up has actually opened up this complete course. And then there is one more course that Caltech University also has opened up where, all the lectures are available online for you to, you can go and read them. That's a very good source for us to get that. That's one question I've got. I think one student also asked, how do I get started? These are the two ways I would say that nowadays the Coursera and all these open courseware are the best ones to start with, and they're available freely almost. Okay. Okay, one of the interesting question I've got. What challenges we have to face when our ML solution contradicts the domain experts and management's prior beliefs? Means there's only, I think, what I would say is data is in data we trust. We must go by that principle, and then if you believe that the data is showing that particular, demonstrating that particular one, that is the best way for us to show, to get the, somebody believe that that's what it is. A simple example I can give you also. One of my example is, for example, when we initially went live, right, on this solution, right, I was talking about initially when we went live, what we saw was they had a challenge saying that we haven't completely closed the loop. Actually, also the self-learning was not turned on, and then there is no way which you validate or recommend. They were not using the recommendations for at least 3-4 months. Then they came back and said, your recommendations, you are saying 75%, but the actual data is what you're showing is very less than that. Then we had to go back and literally go record by record and show that no, this is what it is. So that is one other way. The biggest answer to any of these things, if you're able to do white box, able to have the data that generate that gives your insight, that is the way for us to prove it. Are there any specific certifications that will complement well in the field of ML or AI? See, I think, like for example, there are paid and unknown, the paid and free ones are available, right? I think probably you're doing this PS courses as part of this one. But a lot of institutes that nowadays are running, these courses. I would advise you to, as a next level, once you complete your degree, probably it's better to join, for example, in Hyderabad, you got triple IT that runs online, that runs physical program where you actually go and we can do that. So that is one other way there, depending on the location, depending on the, your interest. One other way could be that, reach out to the online sources, and then that's one other way, a quick way for us to get certification. See, certification is going to help you to an extent, but at the end of it, I think I don't know. I don't know all of you heard about Kaggle or not. One other way could be there are a lot of problems that get posed online. You could really try to attempt it and see the solutions or the problems, and you can work. That is one other way for us to get the experience. I think that's all I have got. Any other questions? I think we are almost close of it. Thanks a lot for all of you for attending the session. Good luck and best wishes. Hello? Hello?